let's go to page 10. We'll go to page 10. And on page 10 we have some special problems. This is going to be, these problems are actually going to be easier than the ones we've been doing. That'll give you something to look forward to, right? Some problems that are easier than the other ones. Actually, and then they're going to get harder in the next section. So you might say this is the eye in the middle of the storm. But before I get into this section, I want you to think about the perfect squares. There are some special numbers. The perfect squares would be like 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, 16. In other words, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared, 36, 7 squared, 49, 8 squared is 64, 9 squared is 81, 10 squared, 100, 11 squared, 121, 12 squared, 144, and 13 squared, 169. Now, you need to know and be familiar with these numbers. I want to show you something I think is interesting about these numbers. Notice the difference between the first two is what? 3? The difference between the next two is 5, and then 7, and then 9, and then 11, and 13, and 15, 17, and so forth. Isn't that neat? Okay? So these are what I call the perfect squares. Be familiar with these numbers to the point that if you see a problem, let's talk about real life. Let's say you're driving down the road and you see a mailbox that says 25 West Oak Street. Then you should say, oh, 25, it's a perfect square. Or if you happen to be 36 years old, then you say, my age is what? 6 squared right now. Or 7 squared, or 8 squared. You're getting ready to retire, and you're 64 years old, and next year you get to retire. So what are you thinking? I'm 8 squared years old. No kidding. Now you don't have to get like that. That's maybe fanatical. But you do have to get so the numbers ring a bell when you see one. To the point that if you saw x squared minus 25, you'd say 25, hey, that's an important number in my life. That's the year that my insurance rates go down, right? That's the year that some of you might be looking forward to. So do 2 sets of parentheses and what? X times x. Now the problem here is there's no middle term. Did you notice that? There is no x term. Is it still a trinomial or is it not a trinomial? I guess you could think of it either way. If you thought of there being a 0x there, then it'd be like a trinomial with the middle term being 0. But also, it's like a binomial because there's only 2 terms, x squared and 25. But now, let's go for this. The first times first would be the x times x, right? What would be the last times last? 25. In particular, negative 25. But let's take the 25 first. What times what would be 25? 5 times 5. Now, what would make it a negative 25? What do we know about this?
Positive times
a negative. All right, so it would have to be a positive times a negative. My tradition is to put the negative first and the positive second, although other people might put the plus first and the negative second. Whichever way you put it is fine. Now, what about the middle term? The outer times outer would be what? 5x and negative 5x, which would be, see, 5x, positive 5x for the outer times outer, negative 5x for the inner times inner, which would be no x. No x. And that's what we need, no x. See, this problem has no x in it. Okay? Let's take another problem. I'd like you to look at number 8. Problem number 8. This is on page 11. Number 8, it says x squared minus 121. Is 121 one of those special numbers that I was just talking about? That's on the list, isn't it? 11 squared is 121. So when you see this, let's do the two sets of parentheses. And just see what you can do with x squared. What would x squared be? XX. Boy, that's the easiest thing in this class, isn't it? XX. And then what about the last times last?
Minus 11.
All right, 11. We'll make one of them minus. And we'll make one of them plus 11, 11. And you're finished. X minus 11, x plus 11. And what if somebody puts x plus 11 times x minus 11? Is that okay?
Same thing.
It's the same thing. It doesn't matter what order you put the answer. All right? Now look at a problem like number 18. Number 18 at the bottom of that same page. Number 18 at the bottom of the page, it says 49x squared minus 81. 49x squared. Now we haven't had one with a 49x squared up front, have we? Okay. By the way, did any of you see the Super Bowl this past year? Wasn't that great? The 7 squareders won. Right?
7 eggs.
So what do we do with this 49x squared? It would have to be first times first is 7x and what? 7x. Okay? And then the last times last,
Minus 9 plus
9, 9, all right?
9.
Last times last has to be 81, and then what? Minus and plus. Now there's one more thing I need to do. I need to check and make sure that there's no x term in the middle of this result. So you see, I did the first times first, my x, 7x times 7x. I did my last times last, but now we need to do the outer times outer and the inner times inner. What's the outer times outer? 63x. And what's the inner times inner? Negative 63x. So you have 63x, negative 63x, and it subtracts out. Isn't that nice? Okay? So that would be factored completely. All right? On page 10, 11, 12, you have more problems like this. And then, guess what? We're going to get back to this two-step problems. Beginning at the bottom of page 12, we'll have two-step problems. Let me show you an example of what I mean by a two-step problem from this section. Like number 33 at the bottom of page 12. The problem says x cubed minus 16x. X cubed minus 16x. And what's the first step in any factoring problem?
X.
Factor the common factor, which is x. So your first step is take out the x. Now, by the way, if anybody's trying to do this factoring in one step, I don't think you can do it. Unless you're better than me, you're not going to be able to do this in one step. I have a lot of people that say, well, let's see, x is a common factor, and then I do this. And you know what? When I see somebody trying to do this problem in one step, I caught some of you. I see some of you doing that right now, trying to work ahead of me, and you try to do that. You won't get it. I don't think, unless you just get lucky. So don't try to do this in one step. If you take out a common factor, that's one step. What would be left if you take out the x?
X squared.
X squared minus 16. Now that you've got the x out, what's left in the parentheses is one of these special problems, which we call the difference of two squares. Difference of squares. You've got a square, x squared, minus 16. And you recognize 16 as a perfect square, didn't you? One of those special numbers? You see? You know, if you work with these things a lot, so you recognize them. When you work with people a lot, you get to recognize them too, don't you? And what happens if you don't work with this a lot? If you don't work with these numbers a lot, you won't get to recognize them. You'll say, 16, duh, what's 16? Okay? You see what I mean? You get used to these numbers. It'll really help you if you get used to those numbers. So what would that be? XX, and then what?
4, 4.
4, 4. That sounds fast, doesn't it? 4, 4? Never mind. Boo, minus, and what?
Plus.
Plus. Now, is there anything I need to remember about this problem that I just forgot to do? What did I forgot to bring down the x? I was hoping somebody would catch me on that. All right, any questions on that? All right. Now, I think you'll find that the problems are very similar to this down to page 13. And on page 13, let me show you a slightly different problem, but not very different. Look at number 48. It says x squared plus 20x plus 100. And this is very similar to something we've already done with one slight change. What could you do with this? There's no common factor, is there? So you start off with two sets of parentheses and start off with what? X for the first times first. And then what? For the last times last. Last times last would have to be what? Get the right color. Last times last would be 100, which would be what? 10, 10? Right? And then make them both plus. Now how did you know? Thinking ahead, it wasn't just the 100 that told you it was 10 times 10, because it could have been 5 times 20, couldn't it? But when you said 10 times 10, you were thinking ahead to the next shot. And what was the next shot? The middle term, which is 20x. And realizing this plus sign, now what's that plus sign tell you? What does that plus sign tell you?
What's in the middle?
The signs are
Alike.
the same, like signs. And that plus sign tells you that it's what? That plus sign tells you that they are both positive. So in other words, this is going to be both positive. Notice it comes out exactly the same, x plus 10, x plus 10. What would be a better way to write x plus 10, x plus 10? X plus 10, the quantity squared. That's the better way to write the answer, and that's the way I would recommend that you write it. Okay? All right?
If we write it that way, is it wrong?
I knew somebody was going to ask that. What if I leave it like this? Is it wrong? No, it's not wrong. If you leave it like this, it's not wrong. But there are some problems in intermediate algebra next term that if you write it like this, you won't see what to do with it next. And you probably won't know how to finish the problem. So it's better to have a habit of writing it in this simpler form. It'll serve you well. Okay? All right, now, after you've done a few of those, you're going to get over to some more challenging problems, like page 15, number 69. And I'm just going to try to, in the time that I have left, I'm going to just try to do a few problems. And number 69 on page 69, number 69 on page 15, and it says x to the fourth minus 81. X to the fourth. What are we doing jumping up to x to the fourth? Is there a common factor first? No common factor, is there? No common factor between x to the fourth and 81.
Yes, there is. I think if you take the square of 81, like
Well,
x,
let me just show you what I had in mind. Let's try to factor this and use two sets of parentheses and do a FOIL on it. You noticed 81's the special number, didn't you? You probably recognize that 81 is 9 times 9, okay? So then what did you do with the x to the fourth? What can I do with x to the fourth? X what?
square.
X squared times x squared would give you x to the fourth, see? So for the first times first, it has to be x squared times x squared. And now what? Now go to the last times last, which is the 81, and then it'll have to be what? 9 and 9. But the negative would make it lost my yellow chalk, negative and a positive, right? Now, can you factor x squared minus 9?
Yes.
Yes, that's a special problem. That would be what? X
X minus 3
minus 3
plus 3.
x plus 3. Do you see that this part right here factors into x minus 3 and x plus 3? Okay? Now I want to look at this part down here. I want to look at this part, which is the x squared plus 9. Do you think we can factor that?
No, just bring it down.
Well, some of you know about this problem, but some of you don't. So I'm going to pretend I don't know anything about this problem. All right, pretend for a minute you don't know anything about this problem. Let's try it. What would you say? X times x, right? XX. That would give you x squared. Now what about the plus 9? To get a plus 9, what would that tell you? Plus 3 plus 3, right? Plus 3 plus 3. Plus 9 would tell you they have to be the same sign. Now, would that give you the right result? What if you multiply the outer times outer and inner times inner? What would that be? 3x and 3x would be 6x. Now, there's no 6x here, is there? So what would you have to do? See, in other words, the middle term has to subtract out. What would you do to make the middle term subtract out? You'd have to have opposite signs, wouldn't you? So we'd have to make this like a plus and make this a minus. Would that work? That would make the middle term subtract out, but what would that give you for the last times last? A negative 9 and not a positive 9. So in other words, there's no way you can do this. You try it, and there's just no way you can factor that, at least not using anything we know about right now. There might be something later that you can use to factor that, but for right now, we just have to leave it as x squared and then plus 9. Right? And that would be your, so this is the final answer, factored completely. All right? Now, I would like to do one more problem with you for consideration. Getting over to the more advanced factoring trinomials, this is your assignment for next time, to continue on and do as much as you can of the rest of this handout. And page 19, on page 19, I need to show you one more concept. And I'd like to take, for an example, number 9 on page 19. It says 7x squared plus 6x minus 1. Now the problem here is it's 7x squared. And there's no common factor. You can't take out any common factor. So we have to factor this trinomial with the x squared having a coefficient of 7. So let me just start with two sets of parentheses. The first times first would have to be what? In order to get 7x squared. The first times first is going to have to be 7x times x. Okay? Now, what's going to make this more complicated is now we've got to get the last times last, so it comes out to negative 1. But the 7 and the 1 here are going to affect the combinations. It's going to be harder to get the combinations. So let's try, well, there's only one way I can think of to get 1, and that's 1, 1, right? So this is going to have to be 1 and 1. So what do we do with this in order to make it work out? We'll have to have a, what, plus 1? If we make a plus here and a negative there, let me see, this is just trial and error. We just have to try this and see if it works. What would be the outer times outer? Negative 7x. It might help to write that. Swing underneath here with a 7 with this and put a negative 7x there. And then the inner times inner would be what? X. Now, would that add up to positive 6x? No, it does not. It adds up to what? Negative 6x. So if it's negative 6x, what do you have to do to make it right? Switch the signs. Make that one negative, make this one positive. Now it's a positive 7x, and this will be a negative x, and that sure enough does add up to 6x, positive 6x for the middle term.
Do that?
What?
Why do you get to do that?
Why?
Yeah.
Why do I get to do it? Well, I have to do that because it's trial and error. It's not a matter of getting to it, it's a matter of I have to do this in order to try it out. Okay?
So it's negative 7x plus...
So it'll be a positive 7x and a negative 1x, which would give you a total of plus 6x. Okay? We'll finish this up and we'll answer questions on this next time. All right? Have a